Before we get started to MPLS and its definition, we need to know traditional IP routing and forwarding, how the traditional networks work and forward traffic before MPLS introduced for deployment. Let's imagine the diagram here. We have the source device with an IP address 10.1.1.1 that needs to communicate and send packets to the destination IP address on the right hand side of the network. The destination IP address is 20.1.1.1. The source IP address will send the packet, and the packet header has the source IP address and destination IP address to be sent from the source IP address to the first router in the network, R1. We have here R1, R2, and R3. The routers together will start to receive the packet, and router R1 will receive the packet from the source IP address because R1 is the gateway router of the source IP address, and the router R1 will start to de-encapsulate the packet and check the destination IP address, which is 20.1.1.1, and try to search this IP address in its existing routing table. If there is a match in the routing table entry, it will decide to forward the traffic out the interface, Giga Ethernet interface 000 to R2. Before it sends the packet, it needs to encapsulate a new header with source IP address, destination IP address, and send the packet. So R1 will do this procedure to be able to send the traffic to R2. R2 will do the same and will send the packet to Giga Ethernet interface 001 to R3, and finally R3 will send and forward the packet to the destination IP address. Each router needs to de-encapsulate the packet and search the destination IP address against the routing table entries and forward the packet to the outgoing interface after encapsulation the packet with the packet header. This is a complete process for the traditional IP routing and forwarding. To summarize what we said, in the forwarding path from the source to the destination of a packet, each router needs to perform the following: de-encapsulate the received packet and obtain the destination IP address in the packet, search the destination IP of the packet against its routing table entries, re-encapsulate the packet after determining the exit interface and next hop IP address if a matching was found. If there was no any match in the routing table entries, the packet will be discarded, of course. The above process may lead to slow performance and processing, of course, because each router needs to perform the above 3 steps, and that will make more processing for large networks. Thank you for viewing this video. I hope it can add a good value to you.